So today we will start from a very unique, I would say unique issue. And this kind of unique issue will happen in your career if you are so familiar with the robotics. Then you join the industry, then you apply the robot to whatever you need. Then you may need this kind of knowledge to, I would say, overcome or say solve the issue. The singularity, they have a definition. That is, I don't have a definition. Okay, they have a mathematical definition, but I want to say something. If you have a robot with 6 degrees of freedom, then in some case you may manipulate one of the joint, but it seems the final result is not what you expect. That's why we say you already face the singularity for this robot. The singularity all depends on what is the mechanical design for the robotics. So it depends on what types of robot you use. So sometimes it is not necessary we have the same solution or have the same mathematical derivation. And for the mathematical definition is if we have a joint 6, when we say rank, if you have an experience for solving the matrix operation, you may know if we have the equation, you have several differential equation or not necessary differential equation. We have several equations we need to solve. So for the easier way is you form it as a metric form. Because a matrix form, if you have a matrix form, it will be easier to inverse or do the ranking elimination, we call Gaussian elimination, then you will have the final result. If you understand what I'm saying, that means your mathematical engineering is great. Yeah, because it is, you will be taught in the second session of the mathematical engineering. Ranking 在矩阵里面代表的意义，就是如果我是4乘4的矩阵，我一定有4个独立解。如果我没有4个独立解，那就表示说它有相依的成分。所谓的相依的成分，就是说我这个解跟另外一个解可能有关联，那就不是独立的解。那这个时候，它的所谓的我还是只知道它叫 ranking 我不知道怎么翻哈。那 ranking 呢就会少于它原来的设定。比方说我的 ranking is 4, but the final result, final answer is maybe only 3 individual independent solution. Then I have fewer than the original size of the answer. Then it means there are some situation happened. Okay, and for the singularity, it's a very similar this kind of question. That is, in some case, you don't have the exactly the answer you need. For example, I just give the example for if you have a 6 degree of freedom robotics, but initially you have 6 motor or actuator to input whatever you need to move the robot to somewhere you want. However, you did, but some joint did not move as you expect because the answer, because the input and the outcome is not equal to the same, then equal singularity. Okay, so it's not easy to understand from one explanation, but later on we can discuss a little bit more because I have a bunch of examples and I would say the example can help you to understand more. Okay, so over here it mentioned about a ranking. Okay, for the ranking session, if the ranking originally is 6 but it's smaller than 6, then it means some joint did not move or did not receive your command and responds the proper reaction, then it means some joint face the singularity. Okay, so we always have a simple robotics type for explanation. For example, over here we have the two-link planar arm. For example, if we have a rank smaller or equal to 2, yes, we have original 2 for the ranking for the system. But if we are smaller than 2, then it means some arm cannot move whatever the angle you input, whatever the angle command you input. Okay. So over here, I think we explained a little bit for the J stands for the Jacobian, is less than its maximum value is called singularity. Okay, so the definition is over here. Okay. And they also, yeah, because I read through the whole textbook, sometimes it's a little bit confused to understand. But yeah, at this point I can share with you. So if you only read one time for your textbook, you may not quite understand what they are saying. Then what will you do? What will you do? I'm not sure this is your reading habit, but you need to read one more time. Leave it and come back to read one more time. And sometimes you get the idea. What are they saying? So if you can understand what I'm saying in English by this way, then you are okay. And your English should be fine. So what I'm saying is for the difficult content of any textbook, just leave it and come back to read one more time. And don't distraction for others. I never distract by other noise because I focus on what I want to say. If you can train by this way, I think it will help for your future career. Okay. Over here, I just want to identify what types of singularity. They are mentioned several reasons. Okay. I try to explain not just from the text itself. Okay. It is a very special word over here, unattainable, something like that. Okay. So in this case, even I need to translate what's going on for this, what is the meaning for this vocabulary? What is the meaning for this vocabulary? Anyone? Unattainable. What is that? Okay. So if one day you can learn some new vocabulary, like you learn the Mandarin, or you have another vocabulary, I give it to you, okay, the Mandarin, then you can learn a lot of stuff, okay. So the unattainable is unreachable. What is unreachable? Okay? You know, I repeat some question for you because I just want to let you feel that if we have some learning we want to say, we want to do, then you better have the desire thinking that I want to learn something over here. Then you will bring nothing back home, okay? So the certain direction cannot reach some place. This is the first item mentioned. So the singularity. And of course, and over here, and in a later definition is so ambiguous. Ambiguous means 模糊. So I would say, okay, we just go through a little bit, then we will see the true case. Maybe will help us to understand. Like a singularity bounded end-effector velocity may correspond to unbounded joint velocity. What does it mean? It's a very difficult sentence. According to my understand is, although I want to move my end-effector, I can move my end-effector in the proper velocity, but it seems corresponding to some actuator I did not manipulate. Unbounded sometimes is called maybe I did not control it, or I control it but it did nothing to respond linearly to my input. So in that case, I will explain by this way. This is I move the end-effector to somewhere with some velocity, but it seems not corresponding to the joint I actually input. It actually controlled by the joint. I did not input anything. Okay, so it's quite complicated. Okay, and the third, again, bounded joint torque may corresponding to unbounded. So it repeat again for the velocity and torque, because we are not necessary, or we are not only talk about the position at this point. We talk about velocity and force. Force means torque also. Okay, so it means I control my torque or I output my torque, but it seems not controlled by the joint. I input the rotating angle, so it's weird. Okay, so it means I cannot control it. So at this point, I think I can conclude something about the singularity is it seems a little bit dangerous if you cannot determine when the singularity event happen. Because if you sell your robotic system to the customer, but the customer apply it to a very spatial path trajectory, then it shows some singularity event, then you did not observe it in your factory, then you will have a big trouble. Okay, so that's why in Taiwan, I need to share with you is in Taiwan, the industry all tend to manufacture the component. What is component? Like we have the pipe, we have the tube, we have, I would say bearing is a little bit complicated component. There are rare company manufacture this kind of component in Taiwan. So the component is something like a very basic parts. Yeah, you can see like a screw. Yeah, screw is a very common one. Okay, for the TSMC, they are not doing a component. They are doing a very complicated processes. This is very rare company. But for the traditional company in Taiwan, they all manufacture the component only. They are rare company manufacture or build up the system. What is the system? Robotics is a system. Machine center is a system. Okay, there's not many. I would say there are not many companies in Taiwan doing this. That's the reason our engineering education is somewhat a little bit different, because with the systematic thinking for the engineering will be different. But it's a good one, because this class is tend to introduce why the system is so complicated. If I want to manufacture a screw, I don't think I need to go through the whole mathematics too many. I would say too much. Of course, we have a research on some kind of component manufacture. How can we manufacture faster and accurate? And we still need a simulation tool. But I would say for the system integration or system design is totally different. Okay, so singularity happen in a complicated, also not complicated only. It is a multi-degree of freedom machine case. Okay, even the machine center 工具机 will show the singularity, but they already avoid this kind of situation in their factory, I would say. Okay, the first one is singularity often corresponded to points in the boundary manufactured workspace, but this point the maximum reach of the. Okay, so normally the singularity happen when the specific structure reach the further 最远的 the further position. So in that case, it will show up. This is one of the case. One of the case. Okay, singularity corresponding to points in the workspace may be unreachable under small perturbation of such a state. Okay, that's the normal. Okay, so eventually we explain over here is it show in some case and it show almost is not unique. So in this class we try to introduce it and try to identify the singularity, maybe posture, 姿态 posture for the system. Okay. And over here we jump to the conclusion is if my determinant for the Jacobian equal to 0 in some case. Okay, in some cases we already find out the Jacobian look like. Okay, so if the Jacobian determinant equal to 0, it means we have some singularity event show up. Okay, so over here there are many number of the method can use to determine the singularity, and over here we use the determinant equal to 0 to determine the kind of situation. And I think it's a good one to explain the decoupling idea over here. Over here we introduce the decoupling concept, okay? Because in the next week we will step into the inverse kinematics, not dynamics, kinematics, okay? For this kind of inverse kinematics is quite important because we need this kind of information to manipulate our robot. Okay, the resulting equation is the final matrix or final equation. We already perform the angle manipulation or operation is okay. Okay, we manipulate like a DH or the rotating angle, anything. Then the final matrix is called resulting equation. Depends on the coordinate frame, okay? And however, the manipulated configuration are geometry quantities independent of the frame, okay? Over here, you try to describe what is the configuration. The configuration is, because it is a robot like our human arm, the configuration is how can we reach to somewhere and what it look like if we rotate into some angle. Yeah, it's totally, let's say it's different because one is through, I would say, from the mathematical point of view. The other one is through and from the geometric point of view, okay? Because we see the structure look like, then we can calculate the angle, the position right away in some way. And if you use the coordinate concept, it's more systematic, but it's not so straightforward. Okay, I would say it try to explain this over here. And okay, he said why we want to do that. Okay. So if we try to solve this kind of issue, we need to decouple our robot somewhere from somewhere. Okay, then it will help us to go through the computing process. Okay, so first is to determine so-called arm singularity, and I missed this part. Recognize the fact that allows to decouple the determination of singularity configuration for loose manipulated with spherical wrist into two simple problems. Okay, so we go to the first example. The first example is for the 6-axis degree of freedom robot. And we divide the robot into two parts. And the first part will be the arm singularity over here. Arm singularity. And we will decouple another into wrist singularity, or wrist part. It pronounced wrist, W-R-I-S-T, don't have of W. Okay, wrist. Okay, so the singularity result for this arm consists for the first three or mornings, and the second determine the wrist singularity. Okay, so the singularity can be decoupled into or the arm part and the wrist part. It's very like our human arm structure. So the arm part will be one, and the wrist part will be the second. Okay, and over here is the equation or the matrix form they want to have. Okay, so if you realize the structure for the Jacobian, then you should recall your memory. What does it look like? How many dimensions it have for one joint? How many degree of freedom, or how many dimensions it have for 6 degree of freedom robot? Okay, and we divide into these two sections. JQ is our whole Jacobian, and we divide through the middle to section 1 and section 2. Section 1 is arm section. When I say arm section. So they contain with 3 degree of freedom. JO is the wrist section. It also contains 3 degree of freedom. So eventually they divide the arm section, the wrist section by this way. But over here they also further divide into the matrix. Okay, but the first question for the 6, the n equal to 6. For J, how many degree of freedom it is? Not degree of freedom. How many dimensions it possesses or it has? How many dimensions it has? Yeah? 6 by 6. Great， 右拳哈。等一下我再拿那个来。Okay, 6 by 6. Anyone know why except the 右拳? Because for one joint, one Jacobian have a 6 by 1 degree of freedom. We have a 6 by 1, yes, in the space, 3D space. So we have a 6. We have a 6 joint. Okay, then we have a 6 by 6. And over here it mentioned we divide by further more. J11, J21, J12, J22. Each of them have a 3 by 3 matrix. It mentioned. We mentioned we need a determinant. The determinant equal to 0. It helps us to define or to search if this structure reach its singularity. So we need this kind of symmetric matrix. In that case, it's 3 by 3, 3 by 3, 3 by 3, 3 by 3. And we also know the element inside because in last week we mentioned what is the upper section, what is the down section. Okay, so upper section and down section. So when you see this one, you may find out J0. Although it just mentioned by this way, but how many degree of freedom this matrix have? You always think about this question. Okay. How many degree of freedom for J0, JO? Although it only have a 6 element. For the JO, it is 6 by 3. As I mentioned, Jacobian itself have a 6x1. I already divided two parts, two sections, so it's 6x3 and 6x3. So although we represent it by this way, but actually here's more, okay? So, and also we can observe from here, yeah, because we have, we already have a concept, hope you have a concept, what is the O603 stands for. It means, because we all have a rotation angle, revolute joint, a revolute joint. So this represents the origin for each revolute joint. From here, we can see, oh, this is a joint 4, 5, 6. Then we have an idea, oh, okay, what's going on? So this is the wrist section, segment. I can say that. Digest a little bit. If you focus on what I'm saying, then you are in a good way. If not, hope you can wake up after almost 30 minutes in a class already. I will not go to the detail for this phone because we already explained last week. If you cannot understand, because we have the practice in class last week, hope it will help you to figure out what's the operation over there. But eventually we try to find out each element for the Jacobian. And later on, we will determine the singularity. Mathematics is boring, huh? Actually, no. Actually, no. Of course, when I'm in your age, I think that mathematics is boring. Maybe not, because I got a high score. So when I have an achievement, I feel better when I learn the mathematics. Okay, so yeah, depends. But later on, I found it can use in a lot of field, for research, for work, for engineering, for living, for investment, especially these days. You know what happened last week? No, yesterday? Our stock market dropped almost 1,000 points. You don't have any feeling for that, then you should have a feeling for that. When I'm in your age, I already have an account and invest in the Taiwanese stock market. And I try to lose money to learn something. Okay. Eventually, it's quite interesting. So later on, after I finish my graduate school, I want to pursue my MBA degree. Yeah, it's no more thinking because I think I may be better suited for a businessman instead of an engineer. Okay, so over here we defined JO is our wrist section. JP is our arm section. Okay, let's go continue. Okay. So because the wrist is intersect at a common point, that's the spatial part. And when you design a robot, don't design whatever you like. Yeah, if you design whatever you like, maybe the user, I think I mentioned that before, follow the international rule. Maybe they have a rule, but they have some kind of agreement, under table agreement. Okay, so they have they define the final three joint is the origin is intersect to each other. So in that case, the JO become more easier because the first three row become to 0, and the last three row, the last one will be Z3, Z4. So in that case, the J matrix, the whole J matrix, the upper right section becomes zero. And in this case, the determinant for J is become to determine Ch4.1 multiplied by Ch4.2, okay? And the Ch4.2 is equal. Here is a very complicated description, but you can look back to the previous class, then you may understand. Yeah, because we have, if I have a revolute joint, for the first three, we will look by this way. For the revolute joint, the last three will become 0, 0, and Z3, 0, 0, and Z4, 0, 0, and Z5, if you recall the memory for that. Okay, and over here, it just mentioned it again. Okay, so it mentioned the Ch4.2 is equal to, it's a 3 by 3 matrix, but it's 0, 0, Z3, 0, 0, Z4, 0, 0, Z5, something like that. Okay, you just want to mention that. It's complicated for reading. Okay, therefore, the set of a singular configuration. Okay. Until this J is not step into the singularity discussion yet, not yet. Okay, and we need to continue because we discussed about the determinant J should equal to 0, then they have some singularity. Okay, but the J is 3 by 3 is very complicated. So they have some technique. They say, oh, for the orthogonal section, if the orthogonal section equal to 0, then my determinant equal to 0. It makes sense. Okay, so the determinant J11 and J22, they should either of them equal to 0, then the singularity situation show. Okay, let me repeat again. As we defined before, the singularity show up when your matrix determinant equal to 0. So in that case, over here is J11 and J22. Either one of them equal to 0, then the J determinant equal to 0. So it will be easier multiply by this way. So either one, they can both become the 0, or either one of them is 0, then the singularity show up. So it depends. But when the J11 show, the singularity happen in the arm section. When J22 show 0, then the singularity show in the wrist section. Okay, that's what they try to define here. Okay. So the wrist structure. Okay, let me show over here. This is the last three. So we call it Z3, Z4, Z5. It's not 6 because we start from Z0. Okay, Z0 is the axis 1. Oh, of course. Okay, so in this case, I want to show you the situation look like. Then we go to the mathematics, the equation. Over here, we define what is the singularity. It means the Z3 and Z5 seems don't make any difference for the robotics. And in that case, is when the Z5 equal to 0 or pi, then the Z3 and Z5, whatever they do, they did not show very significant posture different. So it means the singularity. Because we try to move our robot to spatial posture, right? But if you actually move, but it actually did not move, actually it moved, but it did not move significantly, then it calls singularity. I should not say that, but yeah, it's a very similar idea. Okay, so in this case, when the theta phi equal to 0 or pi, the Z3 and Z5 will co-line. What did I mean co-line? 同一线 So they are all revolute joint. So whatever they rotate, you cannot observe anything outside. Of course, if you have the arm outside, then maybe you can see the spinning. But in this case, it is a singularity station. Okay, so they mentioned about the mechanical limits. Yeah, let's say they will not allow the theta phi, jump into 0 or pi, okay, mechanical limit. And also there are some issues we'll discuss in chapter 5. Yeah, there's a mathematical issue, but for the actually moving singularity issue, they can use the mechanical limit. But in this case, it's one of the cases for wrist singularity, okay, because Z3 and Z5 colline, and they did not show any different, even though I input the command rotate Z3 or Z5. The wrist section or the structure over here, we are connected with our end-effector. So eventually it's quite important also, because whatever we need to perform is we attach to the wrist joint. Let me continue for the arm singularity. So after we discuss about the final end, that's why we call end-effector. Yeah, end-effector. Not the one, wrist is wrist, but attach anything on the wrist section is called end-effector. In this session, okay, we finished the session, okay. But for the arm singularity, we need only to compute J11. If J11 equal to 0, it means they are singularity, show up. And it means it must show in the arm section, Okay, so the arm section, we have 3 cases. Oh, this is from textbook. I organized it into this kind. The first case will be, let's see the figures. I always like to see the figures. This is the joint 0, 1, 2. Okay, so the first 3 joints is our arm joint. Okay, for the elbow manipulated singularity, okay, and the J11. The J11 is we can trace this back to the previous chapter. I already checked. It's exactly the same. Okay, so once you have the J11 and you find out the determinant, and the final result you found is the equation 98. A2 and A3 is the arm length, and the S3 is the sine theta 3, okay, and the others, okay. So in this case, if I need the determinant J11 equal to 0, then the S3 need to equal to 0. So S3 equal to 0 can become the theta 3 equal to 0 or pi. So you already defined the final, not defined the final. You already defined the angle the singularity will show up, which is the theta 3 equal to 0 or pi. Or in the other case, is arm 2 multiplied by C2 and A3. Okay, so either way. Okay, so I know what's going on. I want to show over here. There are 2 types of singularity. Okay, for the first type, 499. For the first case, the theta equal to 0 or pi is the first posture. Okay, if your posture is like a cobra, and when the last arm, the theta 3, point out and point back, it means the theta equal to 0 and theta equal to pi, then will become a singularity. The other condition is A2, C2 plus A3, C23. C23, what is C23? You need to understand, okay? In that case, equal to 0 is the posture, like this one. The posture like this one is the end of the arm 3. The end of arm 3, I'm not sure the length, but once the length collide with the joint 1, it is another case of singularity. For the bottom case, it's easy to explain. Because the bottom case, when you rotate with your arm 1, you will find out the arm 3, the end of arm 3, the coordinate did not change. I did rotate, but it did not change. Singularity. Okay, singularity fast. Okay. So that's what I try to mention. For the first case, why it is called singularity? Because I actually turn my angle, but which one? I'm thinking about which one can be explained for the first case. The first one, you know what is my thinking, right? When a floor extend or for retreat as sure. Okay. For extend and for retreat as sure. Okay, sure. Okay. So the bottom one we can explain better, but the upper one, yeah, I know it's a singularity situation, but how can I explain it is a singularity session? Maybe we go back later on if I figure out or you figure out. Okay. So for the first situation, maybe you can use some programming technique to overcome it. But for this one, it's quite annoying. Okay. So later on, you will find maybe 90% of the arm type. Even for the UR, they design by this way. They have an offset, no matter in the joint 1 or joint 2, it's okay. They always have an offset. They just want to avoid the second type of singularity for the arm session. It's easier if you do the design. And I must say, because we need to install the actuator in between, so we need this offset. So it solves a lot of issue. Okay. In that case, you don't show up the second type. The second type is this type. The second one, the bottom one. You don't show this singularity anymore. Okay. So it will be easier. Okay. That's what he tried to say, but I made it a more organized way. Okay. Why this is second 2? Oh, okay. I have a more. The case 2. I just retreat from the case 2. The case 2 is for when the wrist intersect 0. Okay. In the previous case, same. And over here, it just stretch upper, stretch straight up. Okay. In that case, when you rotate still joint 1, then the position will not change for the arm 3 case. In this case, although it is prismatic, but it doesn't matter. So it sit into his singularity. This is another case. The case 3 is Scara. again, this is a little bit confused from the geometry, but it's easy from the mathematics. For the J11, okay, J11 is the upper left, okay. J11 we have alpha 1, alpha 3, and the result is over here. I already checked, it's the same. Yeah, we introduced before in the previous session. Okay, so over here is correct. And in this case, let's say the determinant equal to 0, so you need to come out alpha 1, alpha 4, alpha 2 equal to 0, then it will show up the singularity. However, it come out the S2 equal to 0, sine theta 2 equal to 0. Then the sine theta 2 should equal to 0 or pi, then the singularity show up. A singularity show up. So in this case, it show from the geometry. Okay, 0 and 180. Then the Z2, the position is different. Yeah, for me, position is different. How come it's a singularity? Okay, and you actually sure, right? Yeah, okay. But equal is a singularity station because it is a straight aligned with the joint 2. Straight aligned with the joint 2. Okay. So this is another singularity example for SCARA. Okay. So to conclude, whatever we mentioned today is we provide a mathematical sense to determine the singularity. And also we decoupled the arm section and the wrist section to observe, because the singularity section different. If we can decouple it, will be easier to compute, also to observe. Okay, so let's probably we finish the singularity introduction. Any idea for that so far? Hope you can have some idea for that. Okay, let's take a break.